Okay, thank you again. We're back to part 2. So, some of the common places that we need to look at when we're looking for rack and pinion problems is parts and sections that can leak oil. We can see there's a seal there, which is like a pinion shaft seal, okay? We can have oil leaking through there. We can have seals on the outside there. Those seals there can leak. When those seals leak, it fills up the rack boot, or the bellow as the book calls it. And you can feel it in there. If the rubber is tight and sealed, and you put your hand on that rubber and you push it, and you'll feel the oil in there if it's leaking, okay? I've seen people change the boot because they've had oil leaking in there, thinking, oh yeah, I fixed it, but they haven't fixed it because the leak's coming from there, okay? We can also have a leak in that seal there. That won't show up as an oil leak, but it will show up in heavy steering because the oil's going to be bypassing where it shouldn't be, okay? There's also pipes going on here. Those pipes, if they're not sealed, they're normally a flared pipe that seals up with the flare. Sometimes they can have an O-ring. So if they're leaking there, that's a source of leak. There's probably a gasket there. There's a slight chance that could leak. There's also the pipe will be, the high pressure pipe will have some rubber clamped hose on it. They can leak as well. So there's lots of areas there around that rack to look for when we're looking for oil leaks. We can also, around the power steering pump itself, we need to be checking for oil leaks around there as well. Okay. So again, we see the word steering gear. We know the gear is a steering box or a steering rack, okay? Gear is just what we call the steering mechanism that gears down the ratio from the steering wheel to the wheels. So we need to carefully inspect the steering suspension components. Wheel alignments are very important. We need to check the wheels are in balance. If the wheels are out of balance and we're going down the highway, when we get up to say 80 kilometres an hour, often a wheel out of balance will start to shake the steering wheel, okay? And then sometimes we get up to maybe 100 kilometres an hour and the shaking disappears. It's because of that point where the balance is most noticeable, because you can drive the wheel faster and after a certain rotation speed, the vibration tends to ease up because we've passed that point where the out of balance is really noticeable. We also have to check tyre pressure. How often do we not check our tyres these days? Tyre pressure, if we've got one tyre a little bit flatter than the other, will affect the steering. Yep. So if we have someone come into our workshop that's got a steering issue, we need to check the tyres. If we've got low tyre pressure, is it going to be easier to turn?
No.
It's going to be harder, that's right. So if we want lighter steering, we put more air in the tyres. We're looking for the worm shaft preload and the selector gear preload. So the worm shaft is meaning a steering box, a worm drive steering box. On the top of the steering box is a plate, and I don't know if you've never seen it, but there's a threaded screw with a lock nut on it.
We can adjust
you can adjust. You've got to be careful you don't over adjust, because you can put too much load on it and that can make it tight. But just the right amount of load, just to take away the excessive movement in the steering box. And the same with the steering rack. On the rack, there is they call it a yoke. I think they call it a yoke cap, and that cap is adjusted, or it's shimmed, or it's got a thicker circlip. You get thicker circlips, but there's a means of adjusting that yoke so it'll go further in, and it rubs up against the actual rack itself, the shaft, and it will actually load that shaft up to take up any excessive movement so that the gear in the pinion gear and the rack gear can mesh tighter, so it's not too loose and there's not this play in it, okay? So that's another critical adjustment. As I said earlier, I haven't had to adjust very many of them, but there are times when you may need to adjust it, so to be aware of that adjustment. And don't over tighten it. All right. So when we're servicing and adjusting the steering box, okay, two common service items are the fluid and the internal play in the steering box adjustment. We just talked about the adjustment being that top adjustment, but the fluid is also very important, okay? With electric steering, we probably use our scan tool. Our scan tool can tell us a lot now because it's obviously diagnosing and putting information that's necessary from different sensors. There's torque sensors, there's steering angle sensors. We can see a lot of those values. For example, if we're in the middle, straight ahead, and I see minus 8.5 angle on my steering angle sensor, I'm awake that there's something wrong. It should be 0, okay? If it's only, say, 0.5, I'm thinking maybe I've got the steering wheel quite straight. But if I had it straight and I was reading that, I'd be wanting to recalibrate I'm going to call it a crank angle sensor, a cam angle, I'm going to call it a cam angle sensor, a steering angle sensor. There's so many sensors in cars. So we need to make sure that that sensor has been calibrated if it's out, all right? And what happens if it's out? It will affect the way the steering feels, okay? The computer knows when you're in that middle straight ahead position. It has a bit more of a, I suppose you could call it tension or loading on the steering wheel, so it's less likely to wander. But if your angle is out, it's going to put that loading further off, so when you turn the wheel a little bit, then it gets a bit bumpy because it's putting that load there, and it's going to want to wander a little bit because it's not loading where it should be. Does that make sense? Okay.
Hi everyone, we're here at John Souders Auto Repair, and a customer requested a video about a steering box adjustment. So we have a Toyota 4Runner pickup, and here's the steering box right here, and you can see I have a box end wrench on the nut, and then it has a slotted screwdriver blade on the top, and some have an Allen wrench on the top. Now here's the steering shaft that's going up to the steering wheel. So how I check these is I move the steering shaft, and it has a lot of play right there, and I look down at the steering. This is the center link that comes off the steering box itself, right down here where my finger's pointed. And if you watch that, you can see how it just barely starts to move a little bit. And I'm moving this upper piece quite a large amount of space here. So there should be just a very small amount of space here, and then this should start to move almost immediately. So what you would do is put your flat blade screwdriver so the screw doesn't turn. Then you loosen your lock nut with the wrench here, and then you turn the screw a half a turn. Then you re-secure the lock nut, and then what I do is I go out and drive the vehicle to see how much plays in the steering and how much improvement I've made. And then I'll come back again and do it again in a half a turn increment. By that point, you should get pretty close to where you have a noticeable difference in the feeling. The steering's much tighter, there's no play in it. If you go too tight, then the vehicle will be over-responsive. When you move the wheel, it'll wander around, it'll actually make the steering worse. So that's why I just go a half a turn, and then I can retest it here after I go the half a turn, and then I'll notice that the steering linkage here will turn quicker with less movement from here. So that's just a little tip from John Souders. You would loosen the lock nut and always have the screwdriver or Allen wrench in place, because when you loosen the nut, a lot of times the whole piece will move. So the adjustment screw will also move. So if you keep the adjustment screw in the same place, then you can do your half turn increments and not lose place where you are. So thank you very much and have a nice day.
Okay, I don't necessarily would drive the car and then recheck it. I would recheck it, but then after I've rechecked it, I was happy. Then I drive the car. I still drive the car because we know if it was too tight. Okay, but yeah, I think it's done a good job of explaining that. Has anyone? You've adjusted the steering box before, Alvin?
Yeah, I've done.
Anyone else? Yeah, a few of you. Good. Did you do it similar? Was that a similar process that you did? Yeah.
Yes, and is that the same thing if you, if you overtake it, the steering when you are turning at the runabout, it will not return when you...
Yes, that's correct. Yes, it gets too tight.
And I have done this.
Yeah. Okay, so we'll talk now a little bit about the geometry of the steering, okay? So we can see here A and B. So assuming A is the front of the car, if we measure from A to A and B to B, okay, whatever the difference is either going to be, if the A is a shorter distance, we will have toe in. If it's a greater distance, we'll have toe out. Does that make sense? So I think that's pretty self-explanatory. Again, we can see the names of these things. Tie rod, steering arm, axle, tie rod, and they call that a centre link. I call it a drag link. The book calls it a track rod. So, yeah. Any other names? Do we agree with tie rods?
Yes.
Sometimes see these axle. I always used to call the axle a stub axle. You know, the stub axle is the part that the wheel bearings go in and that the wheel then goes on.
It's like a stubby.
Yeah. So that's what I would call a stub axle. But I noticed in the book they call that a not stub axle. Now I've forgotten. It'll come to me later when we'll see another picture. All right. Who can tell me what that is? What sort of angle? What sort of angle is that wheel, and what would that measurement be? Anyone know?
Camber.
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 Camber. Camber is correct. So the lean of the wheel. Why do we want camber on a wheel?
It's gonna wear out the tire on one side.
It does, yeah. So if we have too much camber, it's going to wear on that edge that we've got too much, or if we don't have enough, it's the other way. It's going to wear on the inside.
And also when going on the corners,
Yep.
makes difference.
Yeah. So in my early days, everything had positive camber, but now they have negative camber on some of these cars. So it's interesting how things change.
I had a problem with this one, right? We had SLE Komodo,
Yes,
right? V8s,
yes,
and when I lifted on the hoist, both the tires they went in like this, like on the
Yes.
right?
yes.
And then I was looking at it and I go like, hang on, this is not right, because all the time I was thinking like the tires
Yeah.
should go like straight down
Yeah,
and straight
yeah,
up.
yeah, yeah.
So I was looking at it and I go like, and when I put it on the ground,
Mm.
it went with a weight and it went the opposite way.
Yeah, yeah. When you let the springs hang, everything just
Yeah.
drops down. So yeah, that's pretty normal. All right. So yeah, the camber is the tilt of the front wheels inwards or outwards. When viewed from the front of the vehicle, the top of the wheel is usually tilted outwards to give a positive camber. If the wheel is vertical, it is zero camber. If it's tilted inwards, it is a negative camber. Camber also compensates for any defection of the suspension under load. Wheels given internal camber tend to deflate towards the vertical when under load. Because of the design of where the control arms, some suspensions have a natural tendency for camber to be reduced under operating conditions. So it depends how the control arms are. It depends on the manufacturer to whether it has positive or negative camber, obviously. So,
Is this only for independent suspension?
no.
No.
With kingpin bushes back in the old days, I'm pretty sure we used to shim up the kingpin. I can't remember how now. So maybe we can't do it on a kingpin. Probably we can't. But in some of the older cars, on the top control arm, we used to put shims in to adjust the in or out. And we could also adjust the caster by putting more shims at the front to the back or vice versa to change the caster. So yeah, I'm not sure about kingpins. Maybe they're a factory set, but they would probably compensate for some sort of camber, I would imagine. Did anyone see that? Angle of the wheel. What do you reckon that would be?
Wheel alignment?
There's a name for the wheel if it's tilted. Anyone know? Caster. Who's seen a caster wheel?
I know the caster oil is on the chairs.
Yeah.
The
So
chair.
have we got one here?
Yeah. Think so.
Yeah, we have. So can we see that caster wheel? It's not, the axis is offset. Can you see how the axis is offset?
Yeah.
It's not directly under there. It's got an angle on it. And that gives a tendency to roll easier. Okay?
Ah.
So the caster, and gives it easier steering, you know? When you're actually having positive caster, it gives a lighter steering feel to the steering wheel. So caster is all about the feel. Often if a car is has a tendency to pull one way, if our caster is different from one side to the other, we often give it more positive caster on the side that's pulling to compensate, and it generally evens up on the road. So the caster has a lot to do with the way this car steers. Okay?
So how is I didn't get the actual the caster. How does it work on the car?
So in other words, there's the axle there,
Yeah.
and see how the wheel's been kinked over, just like on my chair?
So is that has to do with the struts, like the shocky struts will move back and forward?
Yes, because that will kink it over.
Oh, okay.
Okay?
Yeah, yeah.
So if you have, some cars have what I call it either a strut rod or a caster rod. I call it a caster rod because it has bushes at the front. Falcons in the early days had them where you had adjusting nuts, and you could adjust the rod and make the rod shorter to pull the lower control arm closer to the front or
okay.
push it away from the front, and that would alter the angle of the caster on the tyre.
Okay. So in this situation,
Yes.
so is your struts gonna bolt at one place from the top, right?
Yes.
The gas struts. So
That's
it's
right.
just the bottom line just gonna move forward.
That's
and-
correct. That's correct.
Right. Oh, okay.
Some of the earlier Commodores, we used to have 3 different positions for the strut top to go in,
Oh,
and each one
oh,
would
to
kink,
rotate that.
each one would kink the strut further to the front or further to the back to alter the caster.
Oh, okay.
So that's how we used to adjust that. So there's different ways of achieving your caster, and different manufacturers how they design their suspension. But caster does play a critical part of the alignment. Doesn't really cause tyre wear though.
Oh.
It's more for, I guess, stability and steering properly. Okay. All right. So, Ankerman's steering geometry is the arrangement of linkages that allows the inner wheel to follow a smaller circle than the outer wheel when the vehicle is turned. Pretty much what I was telling you about toe in and toe out on turns, so that the wheel that's turning that way, it's going to turn a greater angle than the wheel on the outside as it comes around, okay?
Is that called something counter? Not counter. Counter steer. Counter steer. I've seen in the race go karts, right?
Right, yes.
So when you go to the certain point,
Yes.
and when you steer that, so one wheel stays there, and after that the next one turns more.
Okay, yeah. I haven't heard about that, but it
Yes,
sounds...
counter steer.
Okay. Oh, I haven't heard that, but I'm sure that,
Yeah, because I've seen in go kart like one wheel stands,
Yeah,
and then goes to the second point, and the other one, and then the other one starts moves
okay.
more.
I know. But there's also steering axis inclination. So the top of the steering axis is inclined to the centre of the vehicle. This gives a better loading to the ball joints and assists in keeping the wheels pointing straight ahead, adding to the vehicle's stability. We can't adjust the inclination of the axis, but if something gets bent, you can guarantee that'll be out. And often if we see that out in our wheel alignment figures, we need to look for something that's not right, okay? It's a physical reason why that's out, because that's factory set.
So that's what we're going to do in this video. Toe is technically a part of the suspension setup that will be adjusted for each particular track. It describes the angle of the wheels relative to the perfect, straightforward direction of the car. So wheels with zero toe will point straight ahead. Wheels with positive toe will point inwards towards the centre line of the car. Wheels with negative toe will splay outwards, like this. Now I'm using extreme angles here to demonstrate the point clearly. In reality, the differences between toe setups will be a matter of maybe 2 degrees either way at most. So what are the effects of toe? Common sense would have you think, just get the wheels pointing parallel with zero toe and then get them moving left and right together as you steer the wheel. Why on earth would you point them off centre? Well, there are quite a few things that are affected by toe angle or toe distance, as you can measure the toe as a difference to these two distances if you prefer. The first thing affected by toe angle is tyre wear. This should become quite apparent if you think about it. With zero toe, the front wheels are pointed straight ahead, so as you drive the car forward, the front wheels are just rolling freely on their axle. If the tyres are splayed out, the inside will be dragging somewhat along the track, heating and wearing the inside of the tread. Similarly, if the tyres are toe in, the outside of the tyre tread will be dragging somewhat along the track, causing temperature and wear issues that will need to be managed. Now again, I've exaggerated the angles, and with only a degree of toe, these problems aren't as catastrophic, but still need to be taken into account. To minimise wear, you'd probably want to keep zero toe, particularly on the straights. Again, all things being equal, zero toe will give you the best straight line speed. If you introduce toe angle to your front wheels, they're wanting to go in slightly different directions than straight ahead, so you're essentially wasting power dragging them along the track instead of free rolling as previously. It may only end up being a matter of a few kilometres an hour, but anyone familiar with Formula 1 knows that the little things soon add up. Thirdly, cornering, agility and handling. Now we move into an area where zero toe might not be your best friend. Let's think about what happens when you turn a corner. Let's imagine you driving your F1 car into and around a right-hand turn. Your front wheel should trace out curves something like this. What's important to realise is the inside tyre is always tracing a tighter curve than the outside tyre. You know, as the turning radius gets tighter and tighter, so you have to steer more and more. So ideally you want the inside tyre to be more angled through the corner than the outside tyre. This allows both tyres to move closely through their turning curves, maximising their grip and increasing your speed and stability through the corner. You can achieve this by angling your front wheel toe outwards. Straight on, yes, the tyres look weird and splayed, again, exaggerated here, but once you turn the steering wheel to drive through the corner, inside wheel is now more aggressively angled to take the tighter line, while the outside tyre is more gently angled to take the wider outside path. Towing your wheels inwards makes the car less planted through turns, as the car is more reluctant to turn, as the closer you get one tyre to the correct steering angle, the more you point the other one away from it, causing drag and resistance at the front end of the car. This leads us neatly to the last major effect of toe, which is straight line stability. Let's put our cars back on a long straight, but think about what we just said about cornering. Toe out makes the car absolutely ready to turn. As soon as you start to angle the steering, the wheels are towed, so they encourage the car to turn in, with the inside wheel angled more aggressively to take the tighter line. This means while the car will keep pointing straight as long as you hold the steering straight down the middle, the moment you make a slight adjustment away from centre, the car is more sensitive to start turning. And holding the steering perfectly centred can be difficult when the car is bumping around or one tyre hits a crack in the road. Little disturbances make the car want to hoik itself left and right. Conversely, when the front wheels are towed in, they are reluctant to turn. They respond much more lazily to steering inputs, which means the car will remain stable on straights, even if bumps and such disturbances jostle the steering around. Now, normally teams lock in a toe setting that's the best trade-off between tyre wear, straight line speed, cornering speed, and straight line stability, as determined by the track and other parts of the suspension design and setup. Most setups are a matter of trade-off, where gains in one area result in losses in others.
Okay, does that help to understand towing and tow out? Very interestingly, a lot of tyre shops that do wheel alignments love to just adjust to toe in and send the car its way, and they've done a wheel alignment, but that's not a wheel alignment. That's only part of the wheel alignment. There's all those other geometry figures I talked about, camber, caster, rear toe in. There's actually the rear alignment now on the vehicle has to be set up before we set the front alignment up. If the rear alignment's out, no matter what we do on the front alignment, we're going to have trouble because the car will want to wonder if the rear's not set up properly. So yeah, there's a lot involved in setting up the alignment. It's not just doing the towing. Some cars are very awkward to adjust. For example, some of the European cars, Mercedes I think could be in that category, you need a special jig to loosen up the rear subframe, to move the subframe and tighten it again to set up the rear wheel alignment. And if you don't do that properly, you won't get the front alignment done properly. So yeah, we have to look at manufacturers' requirements and have we got the equipment to do it or not. So not always. Has anyone done wheel alignments?
Like the old school way.
You know? The old school, I don't know.
Yeah.
Yeah. So you do them, Shushan? Yeah. You do them now or?
Over here, no.
Not here?
No.
No. So you had a machine in Fiji?
We was doing tablet, with the tablet and with the string.
String, the fishing line, old school.
All right. There are better ways. I bought a Chinese wheel alignment and it was nothing but trouble. So I ended up spending, you know, $25,000 on a proper, really good machine, and yeah, it was much better. So you get what you pay for sometimes with equipment. Okay, so when we're servicing a power steering, again we look at the linkage components. We look at manufacturer's recommendation for flushing, and I think every power steering should be flushed at the right time, okay? Even if the recommendation is not to flush them. Same with automatic transmissions. Some manufacturers will say lifetime, fill for life, but I disagree. I strenuously disagree. It's all right for the new car owner.
Anyway, when they give the life of the vehicle,
Yes.
before the life was only 100,000.
That's right. So the life of the vehicle is probably just a warranty period.
Yeah, that's a
all.
warranty period. That's what I say. Fill for life, and this is the life of the vehicle.
Yeah. Okay, guys, keep attention. Okay, electric power steering systems. Okay, testing is performed with the scan tool, a bit different to our mechanical steering. We need electronic devices. In some cases, power assist will be disabled when there's a problem with the steering. Okay, if we've got electric steering, we've still got mechanical part that will work, but there'll be no assistance, in other words. So that gets disconnected because there's a malfunction. So without a scan tool, we're lost. Problems can arise from the steering motor, the speed sensor, the control unit, the module that controls it. If the motor gets too hot, the control module may reduce the current flow, which increases effort on the steering. So it might not completely turn the motor off, but we could have tight steering because the motor's wearing out and so it's getting too hot, and so the computer's sort of trying to preserve the motor life by slowing down the current. So it's a bit more complicated than it used to be when we get electric steering and we get hard steering problems. There's a lot more to think about. Obviously, when we do have a steering problem with an electric car, we will get a light on the dash, which is an indicator for the driver that there's a problem. So even if we don't have a tight steering, we still know there's something wrong if there's a problem, okay? So again, when that light comes on, a DTC. What's a DTC? Diagnostic Trouble Code, okay? So a fault code will come up and you'll read that on your scan tool. In most cases, no power is available when that light comes on. So in other words, there's no power steering in most cases, but not in every case. Again, when we look at our scan tool, we've got a problem. Okay, I've got all these U codes. Who knows what a U code stands for? I think Alvin should know this one. A U code. What's a U code? Remember, a P code is for power control. B code is for body control. C is for chassis. What's U?
U.
U stands for UHART. UHART is a early type of bus network system in joining computers together. U is for a network problem, okay? A network problem.
Honestly, like I've scanned so many cars.
Yes.
and I've never come across a U code.
What sort of scan tool are you using?
I've got Trandon and I've used Snap-on,
Our Snap-on should show you codes if we're going to be.
but I've never come across.
If you've got an OBD reader, it's not probably going to show a U code, because a U code is more like, with OBD2 it's all about emissions, right?
Yep.
So U codes aren't really related to emissions, but they're related to computer networking problems. So in this case, we've got a U2100 CAN bus error. CAN is the protocol that's used for communicating between the different, in the bus. The bus is the communication lines. The bus is the hardware for the communication to happen between the modules in the car. The CAN is one of many protocols that are used. Protocol meaning the system that they use to communicate, because each module is communicating with each other module. If we have a speed sensor, and that speed sensor is needed, and we know it's needed for the speedo instrument cluster. We know it's needed for the engine control module. We know it's needed for the transmission control module. We know it's needed for the ABS module, and so on. It's got to tell everything, all those modules, what the speed of the car is by the CAN bus network system, okay? So it communicates on the network. Before we had these CAN bus network systems, you can imagine we'd have wires going everywhere to feed wires to tell the different modules what the speed's doing. Well, instead of having a massive amount of wiring, we use a network system of dots and dashes, you know, noughts and voltage. Ones and zeros, right? Ones and zeros. On and off. There's a pattern the way they go, and it's a communication way of communicating information on the bus network to all the different modules. All right, so we've got a problem, but we've also lost communication between the engine control module, the power control module, and I don't know what VCM is, but for whatever module that is. Lost TCM is transmission control module. But here we go. We've lost communication with the steering control system. So you get a bit of an idea now. There's a communication problem, and we can go through that system to try and find out where the problem is. Is there a problem from the transmission control module? Is it lost there, so it's not getting to the steering control module? I don't know, but you know, we could start there, for example, and start doing some tests. But those codes direct us to a path, hopefully, to try and find out what the problem is through the scan tool. Again, some more data. This is live data now. We've gone away from the codes. Now we're looking at the live data. And what do we see? We see the motor voltage for the steering. This is power steering communication module. And we can see that we've only got 6 volts positive, 6 volts negative. We can see the torque is at 0.03. The steering calibration 5. Do I know if that data is right? I don't.
Now you have to go to the data provider.
I need to find out some good known data to know if that's right, yeah. But I'm guessing 6 volts might be wrong to the motor. Might be wrong. I don't know though. I don't know. But we would have to do a little bit of homework and find out what's meant to be there.
So what? Oh, sorry.
No, you can tell me.
What's the steering calibration when it says 5? Is it in the degrees or?
It probably most likely is.
So if
And
it's on
the steering wheel could be a little bit like that and saying
so
5.
if it's on the 5 degrees out,
Yes.
so I think the steering shaft torque doesn't match that. 0.3.
Yeah, I don't know that for sure.
Yeah, because once you turn at a certain point, your motor shouldn't be at 0.3.
Normally torque is when you're moving the steering wheel.
Yeah.
So we're thinking the car's idle. It could be normal when it's not been touched 0.03. It could be normal, but it might not be. So we just need to find out good data. Often we need good data from good known cars, and I used to collect a lot of data. I also used to share a lot of my collected data on the TAT site, and the TAT has a huge lot of library of good known data that we can use to compare. The only trap is if somebody in the system doesn't know what they're doing and they put down put up some crook data, we can get caught like that, but probably less likely. But yeah, we need to have some sort of resources that we can look at to find out if that's good data or bad data. All right. So the motor must be positioned properly to provide assistance. So we're talking about the the electric power steering system now. So if we're going to remove a motor, we need it in the correct position. We need to mark the steering shaft before we remove it. The system with a torque sensor must be recalibrated to 0 after some component replacement, or there is a difference in the steering effort, okay, which we talked about, just to recalibrate. How do we recalibrate the system? Who can tell me?
Put the steering wheel in the center and go in the old scan tool. There will be a automatic calibration. You click to that and it will calibrate.
Most scan tools will run you through a systematic way, if there is a systematic way. Other times it's just a matter of having it in the middle. But I think most good scan tools will tell you and give you the sequence of making sure you're in the middle of the steering wheel.
It has got few other, in that section I've seen few other calibration for brakes.
Yes.
There's one for brakes.
There's a lot of calibrations that we have to do now with vehicles. That's why I don't like disconnecting batteries. If I have to, I have to.
Or they wipe off all the...
Yes, all the and we have to redo all that, so yeah. All right. Again, when we do a calibration, we've come to the different, it's under select a test. This is a GM, so it'll be like a Holden in our country. Steering position sensor calibration, so we click on that and go through the process. But there's also a steering turning selection, a torque sensor calibration. So there's a few things that we might have to set up if we do change something on that particular vehicle. Okay, let's consider the hydraulic hoses in the power steering system, okay? Yes, we have to inspect them for leaks, kinks, any defections, sharp bends. What happens if we've got a sharp bend in the power steering hose?
It can lose the pressure.
It will affect the flow of the fluid, the hydraulic fluid. Swelling. When rubber gets, we're using special rubber that is oil resistant, but I guess as things age, the rubber can soften, and if it starts to balloon up, we know we've got to deal with that. Something else, when we replace these hoses, and I've done this before, where I've developed a vibration after I've replaced the hose. It's a trap for players. I went down to the hose place that manufactures a hose, because there's about a quarter the price than the manufactured hose. Got them to redo a hose for me, and it started vibrating.
Or is it just because the pressure was spongy like?
The rubber obviously was a different material, and it wasn't allowing for absorbing that vibration in the fluid because of the high pressure. So we can get caught like that. Customer wouldn't be very happy if they had a vibration feeling their steering, would they? Do not attempt to patch. I hope that no one would patch up a power steering hose. There's not much you can do once they leak. You've got to replace them. And ensure the lines and hoses do not rub up against any of the components. As the car vibrates, they'll end up wearing a hole and causing a leak down the track. So, this is a typical power steering leak. We can see wetness around there, So the high pressure hose, it can spray the oil and can look like it's leaking all over the place. So we just be conscious that, if it's under pressure, we probably need to pinpoint it. It's most likely going to be the hose, but we need to clean it up and see where it's coming from. Okay, we'll talk about four-wheel steer. Who's seen a four-wheel steer car? Anyone? Yes? You seem to be the most knowledgeable here, Alvin. I think you better come up and take my place.
I haven't seen the one that moves full. It's just a tiny bit at the back helps to steer.
Yeah. So Hondas are probably one of the most common ones to have four-wheel steer, but not the only ones.
I think they also use in the parking.
Yes,
Parking assist,
possibly.
parking
Yes,
assist,
yes,
they
yes,
use that
yes.
one.
So yeah, it's becoming more common.
I think I found in Mitsubishi or Hyundai, one of the car,
Yeah.
but it had only a tiny bit of.
Some of them can only be a little bit.
movement.
Some of them turn the wheel opposite
Yeah.
to the way the front wheels are going, make it more tighter turning. So yeah, so we've got a mechanical four-wheel drive system, which is a steel shaft connects to two steering racks. That's one type, which I don't think I've seen. The hydraulic four-wheel steer, which I think are more the Hondas. The rear wheel turns in the same direction as the front. Then we've got the electro-hydraulic four-wheel steer. The rear wheel can turn with or opposite front. Uses computers to monitor and control the steering. So the front might go that way and the back goes that way, so it turns quicker.
The most common ones are with these ones is the bigger trucks where they have the trailer,
Right,
like the long flatbed.
yes,
So all the rear wheels
right.
has got an opposite
Has
turning.
Yeah, I haven't done a lot of truck work, but yeah, I can see that'd be a big advantage. So, typical four-wheel steer. So imagine that's the front of the wheel, and the back are turning the same way.
Right.
And this one is a computer-controlled system, so the computer will be controlling the back wheels to how much it turns.
Is that something wrong with the photo? Because I've never seen the wheel turning in the same direction like that. I've always seen it goes in the opposite.
Not always.
Not always?
No, definitely not always. No, no. But I usually find that the back wheels only turn a little bit, and that looks like
Yeah,
a lot more than what I would have thought.
Yeah.
So maybe the picture's wrong, or maybe it's not. I don't know. But yeah, it gives you an idea anyhow. So, so we've got the front main steering angle sensor, which is down here. Most steering angle sensors are built into the what they call the clock spring. And then we've got a front sub steering angle sensor. This one's taking two sensors for the angle. We've got a vehicle speed sensor. Why would we have a vehicle speed sensor for the steering?
So they do not overturn, or they're gonna lock. They only operate at certain speed.
Yeah,
When-
they give you more steering assist when you're not moving or when you're driving very
Oh,
slowly,
yeah.
because we haven't got the movement, the rotational movement to help us with the steering. So you need more steering. You're pushing against more gravity when you're.
But like all these four-wheel sensors, will they activate like even in the high speed, or it's just like assistant?
That could be
parking?
another reason. That could be another
Yeah.
reason. So you wouldn't think there'd be the need for that. It's more when
Yeah.
you're parking. I think that the four-wheel steer makes a big difference. But I stand to be wrong there. I'm just assuming. But yeah. So at the rear, we also have angle sensors at the rear built into the rack, and a rear sub steering angle sensor. So two sensors in the rear. So and then our computer.
Another one I have seen,
Yes.
like, but not in real life. I was only seeing on computer. You know how the four wheels, they have a spare wheel at the back,
Yes.
right? So now they're starting, that wheel has got a hydraulic system. So you just take your car and park there, and that wheel goes down,
Does it? Yeah.
and then just rolls
Yeah.
your car.
We're getting very lazy, aren't we?
Yeah, I've seen those ones.
Fair enough. So, different types of steerings. The quadra steer improves low-speed turning, high-speed stability, and trailing capacities on trucks, vans, and SUVs. It uses an electronically controlled rear steering system. Rear wheels turn opposite at low speed, so it says only low speed.
Oh, okay.
And high speed, the rear wheels turn in the same direction.
Oh, just to.
So in low speed, they turn in opposite directions. So it answers our question. At high speed, they turn with the front wheels. So they do work at high speed. But that's only on that particular system. So the Acura Precision all-wheel steer, which I think is Honda. Okay, uses 2 separate electric motors, can change each rear wheel angle up to 1.8 degrees. So it's not a lot, just a little bit. Okay. The ZF, the active rear axle steering, used by a few, so not many, but a few European manufacturers, such as Porsche, Audi, BMW, Mercedes, AMG and Lamborghini. This system relies on an electric motor that is controlled by the control module. These are pure by wire systems. So in other words, the back is not a mechanical hookup. It's a totally electric hookup on the back steering. The front would still have some mechanical control, I would imagine. Okay, who's heard of the 3 C's? Three C's are, we need to be concerned what the customer's telling us. If we've got a steering problem and the customer's saying at 100 kilometres an hour my car's wandering, okay, we need to be concerned that the customer knows what they're talking about and we need to verify that. We also need to find the cause. We always need to find the cause. We can sometimes fix a problem but not fix the cause. So if a tyre's worn out and we put a new tyre on that car, have we fixed the cause for the tyre to wear out? No. So we need to make sure we do that. And we need to make sure that we verified that we've fixed that, the correction has been made, that we've corrected the problem. So I thought that was just something to throw in there, the 3 C's. I only saw that when I was doing some study for this course, and I rather liked that, so I thought I'd throw that up on the screen. So often people rush in and fix a problem that they see but not the cause. We don't want to be like that. Like everything, when we have finished our repairs and our vehicle inspection and everything we've done, we always have to do our post-service testings. So, as with all service repair work, the vehicle should be checked for any fluid leaks and test driven on the road. How often do we fix something and not road test the car after we fix it? Is anyone a culprit of doing that?
A few of the things, small things.
Even small things, we should go and road test the car just to be safe. I go one step further and I recommend we road test the car before we fix it, so we know how it drives in case there were problems there beforehand. Then we know, and if there was a problem there, we don't get blamed for it because we know that it was there before, okay? But if we were to just fix the car and then drive it afterwards and there's a problem, we don't know if we've introduced that problem. So I would definitely say drive first as well as after. And fluids have been changed. Check the steering by placing it on both full locks. What I didn't tell you about putting it on full lock, by the way, we put a lot of pressure on the power steering pump. When we go on a full lock, okay, we're actually putting that pretty much the pump pressure to full extreme pressure. So we don't want to leave it on full lock for too long. If we're bleeding the system, and to bleed the system, if I take the oil out or put a new component like a power steering pump, I'll fill it up with new oil. I'll start the car up and let it idle for a while and keep filling up the reservoir. Once I've got it to a point where the fluid level is settled, I'll just shake the wheel backwards and forwards a little bit, just like that, and then I'll go and check the reservoir. Once I get the reservoir to a point where it's not changing when I do that, I will then go to a full lock. When I do a full lock, I'm only holding it for 1 or 2 seconds, then I let go and go the other way, and the other lock for 1 or 2 seconds. I don't want to leave it there for too long. I don't want to over pressurize the hydraulic system by holding it on that full lock, okay? So we all have heard a squeaking belt when we're on a full lock only because we're under a lot of load. I mentioned that earlier in my presentation, that when we're on a full lock, if the belt is a little bit on the weak side, it's going to show up on a full lock because there's more pressure in the system. It's harder for that belt to turn the pump when it's under full pressure. So we don't want to put the pump under too much pressure unnecessarily. But that's how I bleed a system, by going from lock to lock. And once I've done that a few times and I've filled up the reservoir and it doesn't change fluid levels, I'm pretty happy. I will go for a final road test and come back and recheck it. and it's important to do that. But that's how I believe the system. In your assessment, there will be a question about how long do I leave the steering on a full lock? 1 or 2 seconds, okay? That's all. We want to recheck the fluid after it gets to operating temperature. So it's important to get, like we can have the engine running, but really we need to go for a drive and get the fluid up to its operating temperature. And when we complete, you know what? You know how you guys haven't been doing your unit task 2 very well? It's because I haven't been pushing you to do it, and yet I should be, because it's really part of every job. We need to finish our paperwork. If we don't finish our paperwork, we haven't finished the job, we don't get paid for the job. So it's important that we do our paperwork. And always clean up and put your tools away. How many people have done a job and left all their tools everywhere and brought the next job in and not cleaned up before the next job? Anyone does that? Sometimes. Unless someone's honest. Okay, well, are we going to do that in practical class? No. Oh! Thank you, Alvin. But, the moral of the story is, we don't leave a job until everything's cleaned up and put away, because we would have seen that missing otherwise, so yeah.
I didn't steal, I only acquired.
How did I know it was you, Alvin?
Huh? I was the one who left that workshop first.
Okay. Has anyone learned something today?
Yeah.
I always ask that question. I like to hope you learned something. What about you, LJ? Did you learn something today? Or JL, I should say? What did you learn?
LJ Kruger.
So it's a lot to take. Who said you could learn? But look, I now want to open the floor up to some of you guys. Remember I said, those that went to AURTTD002, I said, I'm going to give you a couple of minutes to share something that you learned from AURTTD002 and just your overall impression of AURTTD002, just so I can get some feedback as well. But I'll start by telling you what I learned. I learned a couple of things. It never ceases to amaze me, how much there is to learn in the auto industry, and how sometimes no one can know it all. I can't even teach you everything. Like we talk about steering at the moment. I can't teach you everything about steering because there's going to be something I haven't taught you or something I don't know myself, right? But I've given you a foundation, and that foundation helps you then, and you grow with that foundation, and you'll learn more and more as you go on, and that's the idea of what we're doing. But when I was at AURTTD002, I know it sounds silly, but I always thought a diesel injector, there was a solenoid injector. I always believed that it was the same principle as a petrol injector, except obviously there's more pressure in a diesel system. And I assumed that the solenoid would lift up the pintle like it does on a petrol engine and let the diesel flow in and close. But I learned at AURTTD002 that's not the case. All it does is it bleeds off. There's pressure. There's pressure, right? There's a spring, a very tight spring in a diesel injector, and there's hydraulic pressure from the actual diesel pressure in the fuel line, right? That's obviously assisting the spring, right? But when the solenoid opens up, it dumps that pressure, so there's no more pressure then, and then the spring becomes greater because there's no pressure behind that pintle, and the spring is what opens the pintle. Okay, it's not the magnetic solenoid like I thought it was. So that's one thing I learned. I also learned, I didn't understand that the vehicles right back until 2014 or wherever, it might be even older, I didn't realise how much information is kept and recorded when there's an accident, when the airbags go off. And that the airbags was a module that actually stored that information, and that insurance companies and others can reclaim that information to find out and understand how that accident occurred to a certain degree, or what the bit like the little black box in a plane almost. It records things. That surprised me. But it also records after the accident. Even if the battery is disconnected because of the accident, there's a capacitor that will keep that recording for a few seconds after the accident. So there's a couple of things I learned, and I thought, you never stop learning, no matter how much you learn. Yes.
That's a quick one. I've come across I had 2010 Dodge Nitro.
Yes,
This lady was driving this car and went down the ditch,
yes,
and the car was right off
yes,
to the insurance company, and she went to the court and claimed that the airbags thing
yes,
came up.
yes,
So the insurance company went and hooked up
yes.
system to that and told her she wasn't